Hello everyone, I'm going to start the next series of the lecture for the microprocessor. Today we'll start with the instruction set of the 8085 microprocessor. Detail about the instruction set. In my previous lecture I have discussed the primary part or the basic part of the hardware, that is architecture of the 8085 microprocessor along with its operation. There are a few more things related to the architecture that I left behind. Let me start with the instruction set so that we can start writing our programs, assembly level programs. Okay, so to start with this instruction set of Intel 8085 microprocessor, first of all you should understand what is instruction. As you know, any computer or any microprocessing unit or as a whole microprocessor can receive data from the user, ultimately process, that is why its name is the processor. So it processes data and the result is sent back to the user. So computer simply performs, computer means I am merely talking about the processor or the CPU, central processing unit, primarily or simply performs a given task on a specified data in response to certain instruction. Now what is instruction? Instruction is a particular command which has been given to the computer or to the CPU to perform a specified operation on the given data. So instruction is a command for a particular operation on a given data. So therefore we need to understand two things, opcode and operands. So what is the opcode? Opcode is the instruction code or simply the instruction, and operand is the data on which the instruction or the command to be operated on. So as you understand, each instruction contains two parts, opcode and operand together. So the first part of the instruction, that is the opcode, which actually specifies a particular task to be performed by the computer or the CPU, which is called opcode. And the second part, that is the operand, which is the part of the second part of the instruction, is nothing but the data to be operated on, which is called operand. The operand or the data may be in various forms. It can be of 8-bit or 16-bit data. Sometimes that operand can be an address also. Address means it can be the address of the memory or it can be the address of any I/O ports. So that address can be also 8-bit or 16-bit. Or sometimes this data can reside anywhere within the register of the microprocessor. So that register where your particular data is present can also be considered as an operand. Or sometimes your data can be there inside some memory location. So then that memory location where your data is present can also be considered as the operand. So I hope this opcode and operand is clear to you. Now coming to the instruction word size. As you know, a digital computer or a CPU or a microprocessor ultimately understand the instructions or the command which is being written in binary only, that we call as machine code. Okay. So the machine codes of all the instructions are not of the same length. Sometimes it may be of 8-bit, it may be of 16-bit, it may be of 32-bit, like that. According to the word size, so based on that word size, the Intel 8085 microprocessor instructions are being classified in three categories. So there are instructions in microprocessor 8085 which is only of 1 byte, that is 8-bit word length, or can be 2 bytes, that is 16-bit of word length, or can be of 3 bytes, not more than 3 bytes. So therefore in 8085 microprocessor the word size, word means I'm merely talking about the binary word or the string of bit to represent a particular instruction, can be either 1 byte, that is 8 bit, or 2 byte or 3 byte, not more than 3 byte. For example, in case of 1 byte instruction, this is an instruction in 8085 move A, B. I'll explain each of these instructions later on in detail. For the time being, it's just an example. So this MOV is called a mnemonics. Machine does not understand this mnemonics. This MOV, MVI, LXI, these are called mnemonics. Mnemonics are the English-like words. Does not have any abbreviation, does not have any literal meaning. It's just like English-like word for our convenience, for human understanding. For each of these mnemonics, there is a machine code or binary code available, designated binary code. So for the time being, this move A, B is an instruction which is of where the output is of 1 byte, that is 8 bit. The meaning of this instruction is, say some data is already there in register B of the 8085 microprocessor, will be copied to the accumulator. A means accumulator. So the meaning of this instruction is move or copy the content of the register B to the register or the accumulator A. It does not delete the content of B. It is just copy and paste. Similarly, for 2 byte instruction, this is as an example, MVI B, 08. So this H stands for hex. These data are in hex. That is why this H is for hex. So 08 hex is your data, which is along with the instruction is given. This data is copied immediately to register B. So MVI means move data immediately. Which data? The data given along with the instruction, that is 08, to the register B. Similarly, for the 3 byte instruction, as an example, LXI H. So this H representing here its L register pair. Okay. So as I know, as already discussed in the 8085 microprocessor, there are 6 general purpose registers B, C, D, E, H, L, and also I mentioned that there are 3 pairs possible, B, C, D, E, and H, L. So here, when it is H written along with LXI, it represents H, L register pair. And this 2020 is the memory address. Okay, 16-bit memory address. Since it is in hex, 4 digit in hex means 16-bit in binary. So it means load this memory address 2020 to the HL register. Since it becomes a 16-bit, single register cannot hold 16-bit. Single register can hold only 8-bit. So what will happen? This first lower byte, that is your 20, will be loaded to L register, and the higher byte 20 will be loaded to H register. So HL will hold 2020 once this instruction will be executed. So these are the 3 examples only. There are many instructions are there. We'll explain the instruction one by one. So here thing is that in case of 8085 microprocessor, there can be instruction of 1 byte, 2 byte and 3 byte, not more than 3 byte. Now come to the instruction and data format. So data format means how length of word length of data that microprocessor can handle. As already I mentioned, Intel 8085 is an 8-bit microprocessor. What does it mean? It means it can handle or it can operate a data of 8 bit at a time, mind it, at a time. It does not mean that it cannot process 16-bit data or 32-bit data. It can, but at a time it can process a data of 8-bit. That is why this 8085 is an 8-bit microprocessor. So therefore, the memory that you are going to connect with your 8085 microprocessor must have the capacity to store 8-bit in each of the location. So a memory location for Intel 885 microprocessor is designed to accommodate 8-bit data in each cell, each memory location. Now what happens if I would like to process a 16-bit data? So obviously you have to use two memory locations to store your 16-bit data. Obviously both the memory locations should be consecutive memory location, one immediate after another. That is, suppose one is your 2000 address, another one should be 2001, not 2002 or 3 like that. So if 16-bit data are to be stored, they are stored in consecutive memory location. And you know already the address of the memory location is 16-bit, that is your 2 byte. Now, how can your microprocessor 8085 or any other microprocessor will identify that where is its data to be operated on? Because ultimately the processor, the purpose is to process data, operate on data based on given instruction or the opcode. So it has to have the data. So before operating, microprocessor should understand or should identify where is its data to be operated on. So based on that criteria, the various techniques to specify data for the instruction, any kind of instruction in 8085 are of 5 types. So what are those? Number one, 8-bit or 16-bit data that you may directly given in the instruction itself. That is one. It's something like this. So where 8-bit data is directly given in along with the instruction itself. So microprocessor will understand that this 08 is the data to be operated on. What is the operation? Operation is to copy. What to copy? The data given along with the instruction. Where to copy? To the register B. So in this instruction, this 8-bit, 08 is an 8-bit data. So this 8-bit data is given along with the instruction. So your 8-bit data may be directly given in the instruction. Or in case of 16-bit, suppose this is another instruction. What is the operation to be performed? The operation to be performed here is to copy. What to copy? This 16-bit data. Where to copy? To this HL register pair. So since it is a 16-bit data, that's why you need to have a register pair. So H stands for here actually HL. But here this MVI B does not stand for BC, it is only B. Along with LXI only, it represents pair. So this 16-bit data to be copied or moved to the HL register pair are given along with this instruction. Okay, so that means without this data or without like this any 16-bit data, this instruction is meaningless. So therefore, in the first case, 8-bit or 16-bit data may be directly given in the instruction itself. Second method of or technique to identify the data is the data may be anywhere in the memory location. Anywhere in the memory location, or it may be anywhere in the I/O ports. I/O port means the input-output device or any output input-out device. Okay, where data resides, that means in this I/O port or memory location or I/O device, your data is there. Then that I/O port or the memory address can be given along with the instruction itself. In the third process, in some instruction, only the register is specified. For example, this is one of the such type. So here, only register, no data is given. The instruction move means copy. What to copy? A data. From where to copy? From register B, because means your data is there already inside the register B and you need to copy it to the accumulator. So you are specifying the source from where the data will be copied as this register B in this instruction. and where 2 copy is accumulated. So this is of this third type. In some instruction only register is specified. The content of the specified register is one of the operand. It is understood that the other data is already there in the accumulator if it is any arithmetic. For example, add b. For example, add b. The meaning of this instruction add b is, the meaning of this instruction add b is that it will add the content of the register b. Okay, so where is your data? Data is in your register b. Since it is the addition operation, this is addition operation, the operation is addition, so you know for addition at least 2 data should be there, but I am specifying only register b. So that means your one of the data is there in register b already. So where is the other data? Other data has to be there in the accumulator, as I have mentioned in the previous class, that before executing any one of the operand means the data has to be there in the accumulator. Okay, so microprocessor is already understood that another data is already there in the accumulator, so directly it will add the data reside inside the register b with the data already there in your accumulator, and result will be placed into the accumulator directly. So as you can see here, I have not specified the data. Where is the data? Data is in register b. I have specified the register b, and it is understood another data to be added is in accumulator already. Okay, this is of this type. Another type can be, technique can be, in some of the instruction specifies 2 registers. The content of the registers are the required data. Okay, like this one register, there can be some instruction where 2 registers are specified. And in some instruction, data is implied. The most instruction of this type operates on the content of the accumulator. For example, in this case, for example, CMA. There is an instruction in 8085 called CMA. As you can see here, I have not specified any data, not specified any register, not specified any memory location, nothing, only this. So it is understood that the meaning of this instruction is to complement, first complement. Okay, once complement of the data. So where is the data? Data is in accumulator. It is understood. It is implied that data has to be there in the accumulator beforehand, before executing this instruction. So this is another type. Okay, so these 5 different ways only you can specify your data. Now the technique by which, so these 5 techniques should known to the microprocessor through instruction only. So the technique by which microprocessor will identify that where is its data or operand to be operated are called the addressing mode. Okay, this is what we call addressing modes. So what is addressing mode? Each instruction requires a certain data to be operated on. This is clear already. So there are various techniques. These are the techniques. These are the techniques. There are various techniques to specify data for instruction. These techniques, the techniques are called addressing mode. Okay. As you can see, there are 5 different techniques. Based on that, there are 5 different addressing modes available in 8085. So in 8085 microprocessor, there are 5 types of addressing modes. What are those? Immediate addressing mode, register addressing mode, direct addressing mode, and register indirect addressing mode, and implied or also implicit addressing mode. Now I will tell you one by one. What is immediate addressing mode? Immediate addressing modes instructions are those instructions in which the data is the part and parcel of the instruction itself. That means the instruction in which data is there along with the instruction are the immediate addressing mode. So in immediate addressing mode, the source operand is always the data. If the data is 8-bit, then instruction will be of 2 bytes instruction, because the data is the part and parcel of the instruction. So without data, those instructions are meaningless. If the data is of 16-bit, of course, it will be 3 bytes. For example, MVI B, 45 hex, as like this instruction, 2 byte instruction. So this MVI B, 45, this is the instruction. Better we write H. H means hex. So MVI B, 45 hex. So this 45 hex is a 8-bit data. The meaning of this instruction is to copy this data to the register B. Move the data 45 immediately to the register B. So you see, if you are not giving any 8-bit data here, only MVI B, it is meaningless. Okay? It is meaningless. So only when you give an 8-bit data along with this instruction, then only it is a complete instruction. So this data is a part and parcel of this instruction. So together, for MVIB there is an opcode, dedicated, designated opcode, and so that opcode is of 8-bit, 1 byte, and this data is of 8-bit, that is 1 byte. Together is the 2-byte instruction, and it is immediate addressing mode because the data is given immediate after the opcode. Similarly, LXI H, already as I explained LXI H. So when it is LXI, it means it has to have a 16-bit data. And as I mentioned, when it is LXI, it is H actually specified HL register pair, not only the register H. Okay, so it's a 16-bit data because it is 3050 hex. So it is 16-bit data. The lower byte, that is your 50, will be copied to or load to the L, and 30 will be loaded to H. So load the HL pair with the operand 3050 immediately. So this is also an immediate addressing mode instruction because the data to be loaded in HL register pair are given immediate after the instruction. So therefore, here for LXI there is a dedicated, designated opcode, and which is of 8-bit, 1 byte, and for 3050 it's a 2 byte. So together it is a 3 byte instruction. Similarly, another instruction, jump address. This address is nothing but a memory address. So of course you know this memory address is of 16-bit. So jump means the program control, that means primarily the program counter will loaded to it this address, and in meaning wise we can say that jump the operand address immediately to this address. So these are some of the examples of immediate addressing mode instruction where the data to be operated are given immediately after the instruction. Second is the register addressing mode. So register addressing mode means the data to be operated on are already there, should already be there in any one of the register, and the register where your data resides are given along with the instruction. That is what is register addressing mode instruction. So in register addressing mode, the data to be operated is available inside the register or registers, more than one, and are the operands, and those registers are specified along with the instruction. So therefore, the operation is performed within the various registers of the microprocessor. For example, move A, B. Already I explained what is move A, B. The content of the register B will be copied to the register A or the accumulator. So where is your data? Data is in your register B already. So what you are specifying in the instruction? The register where your data is present, and to the destination register. So this is the register addressing mode instruction. Move the content of register B to register A. Similarly, 8B, another instruction already as I explained. So to perform any arithmetic or logic operation, it is implied or it is it has to be there that any one of the operand must be there in the accumulator. Now if the second operand, the second data to be added, is in register B and you are specifying the register B along with the add instruction, it is register addressing mode instruction. Add the content of register A with the register B and store the result into the accumulator, meaning of this. Now INR A, another example. So INR means increment. Increment means incremented by 1 only, remember. So what to be incremented? A data. Where is your data? Data is in your accumulator already. So that accumulator, the register, it may be INR B also, C also. So INR B, suppose. So the data is there already in a B, you need to increment it. So INR A, B or A. So you are specifying the register where your data is resides. Increment the content of register A by 1. So these are the example of register addressing mode, also called register direct addressing modes in some books. But there is a particular direct addressing mode instruction. Okay, so direct addressing mode instruction means if you are giving the memory address of the data to be operated on along with the instruction. That means suppose you are copying, you are adding some data, you are moving some data, copying some data from the memory. Okay, so that means your data is in somewhere in the memory. Now along with the instruction, if you are giving the address, memory address of the memory location where your data is there, then it is direct addressing mode instruction. So in direct addressing mode, the data to be operated is available inside a memory location, and that memory location is directly specified as an operand along with the instruction. The operand is directly available in the instruction itself. For example, LDA 2050. So the meaning of this LDA is load accumulator directly. The meaning of LDA, load accumulator directly. So load accumulator directly means you are loading accumulator. That means you are copying something to the accumulator. Okay, what you are copying? Accumulator is an 8-bit, so you are copying an 8-bit data. Where is your 8-bit data? Somewhere in the memory. What memory? Particularly suppose this is the address of the memory where your data is present. So you are giving the address of the memory where your data is present directly with the instruction is of the type direct addressing mode instruction. Okay, so the meaning of this is it will load the accumulator with the data which is present inside the memory location whose address is 2050. So load the content of the memory location into the accumulator. Similarly, another instruction LHLD. The meaning of this instruction is load each cell register pair directly. So you can load each cell register pair. Okay. As you know, this each cell register pair becomes 16-bit destination, because it's a pair H and L together, it becomes 16-bit. So you are now loading that HL register pair. That means you are copying some data to the HL register pair. From where you are copying? From memory. Okay. Now as you know, in the 8085 the memory, each of the memory cell or location can contain only 8-bit. Now you are copying a 16-bit data because you are specifying HL register pair. So that means there should be 2 memory locations. Suppose, and remember, in this type of cases, those 2 memory locations must be consecutive. For example, one is suppose 2020, then other must be 2021. So, but you are specifying here only 2020. This address means you are specifying only one, obviously the first one. Okay, and it is understood to the processor that it will copy the content of the memory location whose address is given here to the L, and the content of the memory location whose address is one more than this address, that is, suppose it is 2020, then one more that means 2021. So from 2021 it will copy to H. So load the content of 16-bit memory location into HL register pair. Content of 16-bit memory location, that is 2 consecutive memory location. Okay. So where is your data? Data is in 2 consecutive memory location, where you are specifying only first one along with the instruction. So that is direct addressing. Another example is this int35. So this 35 is nothing but an 8-bit port address, not the memory address, because memory address should be of 16-bit. This 35 is a port address, that is address of any hardware extra IO device you are connecting. In means copying in, getting in to where? To the accumulator. It is not mentioned accumulator, but it is implied that it is accumulator. So data will be copied to the accumulator from where? From a port. The address of the port is given along with the instruction direct. So it is a direct addressing mode instruction. So read the data from the port whose address is, it's not 01, it should be 35. Okay. So that is all about the direct addressing mode instruction. Now fourth addressing mode is the register indirect. That is important. In register indirect addressing mode, here we will consider a virtual register named as M, capital M, capital M. So the meaning of this is, whenever we specify capital M, it means it indicates a memory location. This M means a memory location, a particular memory location. But provided that memory address of that memory location must be stored presently within the HL register pair. Only HL, not the BC, not the DE, only HL. Okay, so M specifies the memory location whose address is currently present inside the HL register pair. Okay, so here move, already you know, move means you are copying. What to copy? Some 8-bit data. Where to copy? To the accumulator. From where? From a memory location. But you are not giving the address here. You cannot give the address along with the move. But instead you are giving M. So it means, this M means indirectly it's specifying the memory location, provided that address is in HL register pair only. In the previous lecture I mentioned one thing, that HL is a special register pair. This is the specialty. There are 2 specialties. One specialty is this. Because if you store a particular memory location, address of a particular memory location inside HL register pair, then presently that memory location can be considered as like a register named as M. So whatever be the things you can do with B, C, D, E, HL, you can do with M also, provided that memory location should be presently there in HL register pair. So that means you are indirectly specifying the memory. That is why it is register indirect addressing mode. So wherever you see M in any instruction, that is register indirect addressing mode. Okay. Another one is LDAXB. Now LDAX means also load, as like somewhere here, yeah, this is LDA also load accumulator, LDAX is also load accumulator. Now if you see the difference, here LDA also load accumulator, here also LDAX is load accumulator. Now in this case, load accumulator directly from where? From a memory location. because accumulator is 8 bit. So you are copying an 8 bit data to the accumulator. From where? From a memory location whose address is directly given along with the instruction here in this case. But here in this case, this is also load accumulator. Where from you are loading the accumulator? From the memory. But you are not specifying the memory address directly. Instead, you are specifying a particular register. Now, as like in LXI also, as here in LXI, somewhere I have mentioned LXI, when you specify one register, it means the pair, HL pair. Similarly, along with LDAX also, if you specify one register, it means a register pair, B for BC, D for DE, H for HL. So LDX B means you are loading accumulator with an 8-bit data. Where is your data? Your data is in memory location. But the address of that location is now currently in BC register. So you are indirectly specifying the memory, but the address is not given here. But instead that the address is in BC register pair, and you are specifying BC register pair here. So the meaning of this instruction is move the content of the memory location whose address is specified in BC register pair to the accumulator. Here move the content of the memory location whose address is in BC register pair to the accumulator. Okay. Similarly, this is not the example of this. Okay. So you got it now, register indirect addressing mode. Next is the implied. That implied addressing mode already, as I explained, there are some instructions where you have neither specified the data nor specified the memory address nor specified any of the registers, only the instruction. So particularly the CMA already I explained. The CMA means complement, once complementing of what? Of some data, obviously 8-bit data. Where is that data? Nothing is specified here. So it is implied that the data is in accumulator. So that is what is called implicit addressing mode. In implicit addressing mode, the operand is hidden and the data to be operated is available in the instruction itself. Similarly, this RRC, rotate right, RLC, rotate left. What to rotate left or rotate right? The data, 8-bit data, where is that data? In the accumulator. So these are called implicit addressing mode. Okay. So these are the prerequisite things before starting the instruction set of 808. The instruction, what do we mean by instruction? What is opcode and operands? What is the word size of the instruction? Now the data formats of the instructions, addressing modes. Along with that, as I already mentioned in the previous class, the hardware part is not yet being finished. As I mentioned, two more important things, that is one, timing, because microprocessor is a clock driven circuit or IC, so therefore it operates in a particular clock speed. So therefore it's a part and parcel of the hardware that to execute a particular instruction, how much time it will consume, how many T-state. T-state means one time period of the clock. So how many time periods of the clock it will consider, what will be the machine cycle, what will be the fetch cycle, what will be the execution cycle, all those things, the meaning of which I have not yet covered. We will do later on. Before that we will finish up the instructions so that you can start writing your programs. Symbols and abbreviation, this means I'll update this time to time. These symbols means the symbols that we will be using for explaining the instruction, and abbreviation we will be using for explaining the instruction, not for the opcode or anything else, only to explain a particular instruction, whatever be the symbols and abbreviation will be used, those are particular symbols and abbreviation, that is I'll mention here, nothing to worry about it. Okay, now I'm going to explain in my next lecture the detail about the instruction set one by one, all the instruction of 8085, where while we explain each of the instruction, few things we will consider to understand the instruction. Okay, the different parameters to be considered for explaining the instruction are: number one, we'll consider the mnemonics. For example, this RRC or RLC, this MOV or CMA, LDX, these are called mnemonics. Mnemonics means an English like word, does not have any literal meaning, does not have any abbreviation. Okay, next we'll consider the technical meaning of the instruction. Okay, followed by literal meaning or simply technical meaning of the instruction. Okay, so next we'll consider we'll find out the addressing mode of that instruction. Next we'll consider the word size of the instruction. Okay, that is whether it is, because in 8085 there are only 3 different word size, 1 byte, 2 byte or 3 byte. So we'll find out for a particular given instruction what is the word size, whether it is 1 byte or 2 byte or 3 byte. Then we'll consider the addressing mode, what addressing mode it follows, addressing mode of the instruction. Okay, then as I mentioned in the previous lecture, that the decision making box or testing for condition in 8085 is the flag register. Okay, so after executing the instruction, microprocessor will look at the flag to take the decision on the results. Okay, so therefore while your microprocessor execute or operate any operand or any instruction on some operand, flags will be affected, and accordingly you can take, or your processor can take decision based on the flags being affected. So while understanding, while discussing, while studying the instruction, you should know what are the particular flags. There are only 5 flags. So what are the particular flags being affected and how it being affected after executing that particular instruction. So flag affected due to the particular instruction. Okay, then what we'll see, the machine cycle, because as I mentioned that it is a clock driven circuit. So how many machine cycle it takes, a particular instruction takes to execute machine cycles, and in each machine cycles how many t-state means, t-state means one clock period, how many clock period it requires, machine cycle and t-state for the instruction. And finally what we'll see, the instruction format. So instruction format will give you the opcode of the instruction. Okay, so these 8 are the things we'll discuss for each and every instruction while we'll go through. Okay, these are the things that we'll consider while discussing the instruction. So for each of the instruction you should know the mnemonics, you should know the meaning of the instruction, what it is, what it will do, how it will do, then what is the addressing mode of that instruction, what is the word size of the instruction. Addressing modes I have written twice, no? Addressing mode of the instruction. So addressing mode of the instruction, word size of the instruction, flag affected, total 7. Flag affected due to the instruction, machine cycle and the T-step, and finally the instruction format to find the opcodes, because opcodes are the designated opcodes for each and every instruction. So these 7 are the things to be considered while discussing each of the instruction, and you should remember, actually not remember, you should understand these 7 things behind for a particular instruction. Don't worry, you need not to remember all these things for each and every instruction. You need to understand. Later on, slowly you'll understand automatically. While I write an instruction, you'll automatically come to know what is the meaning, what is the addressing mode, what is the word size, what will be the flags being affected, what is the machine cycle, T-state, and format. You will understand automatically. Okay. Thank you. In the next class we will discuss instructions one by one, and we'll update in this same file, same documents only. Thank you.